Okay, so in this video, I'm going to introduce the visual programming interface for the ExpEYES app. It will also work with the Seelab device. So visual programming is basically drag and drop blocks where you create a program structure by attaching blocks like that. So here I have a loop which says repeat 10 times. Inside that loop, I have first let me print. What do I print? The voltage value from A1. Now A1 is connected to a sine wave, so it will be random values between -3 and 3 volts. Wait 0.1 seconds and just keep doing that 10 times. And all these blocks are on the left. So you have variables, you have values, operators, you have loops, you even have all your measurement tools for the devices. So let me just run this program. So you see, as expected, you have random values between -3 and 3 volts. And there's a whole bunch of examples here in getting started. For example, you have everything from the simple hello world to let's say print a multiplication table. So if you want to print a multiplication table, you have a loop. This is a for loop. It takes a variable I from 1 to 10 in steps of 1 and essentially prints out the loop, which is 5 times whatever the value of I is at that particular iteration equals 5 into I calculated, and this is the output that you get here. And the corresponding Python code is also generated. So, while you're creating stuff with your drag and drop blocks, you can also sort of learn Python along the way. So let's see how this works with the Seelab blocks. Let's try and analyze a single trace using the oscilloscope. So as I said, A1 is connected to the sine wave. So the first block is to set a trigger. That's just 1 time. Then repeat 10 times. From A1, get 1000 voltage readings with 10 microseconds between each reading and store them to variables called timestamp and data1. So these two variables will now be available here. Now, once this block executes, you can plot X array versus Y array where timestamps and data will be plotted. So these have already been set by this block, and the plot will be called myplot. You can call it any name. And we can also print the frequency by analyzing these two data points. So this basically does a curve fitting with a standard sine function and tells you what the frequency is. Now let me run this program. So you see the scope pretty much worked. You got 10 traces and you also extracted the frequency here, right? Now this is being printed in separate lines. So you can take out, instead of the print block, you can take the label block. So I'll take the label block. And the parameter is frequency. It's any label basically, and corresponding to that label we're going to put a particular value there. So this will stay in one place instead of printing in different lines. So you see here you have just one line and it'll keep updating. So if you're making simple programs, you might want to use the label block also if it's a small variable that just needs to be shown somewhere in the corner. So that's one program, and there are plenty of experiments like clipping, clamping, a whole bunch of everything has a help file that goes with it with basic schematic instructions, etc. So you see capture and plot something. This is diode clamping, I think. Diode clipping. And this will give you a slider and a frequency slider for the waveform generator. Okay, so the frequency adjustment is not there. So I can just go to the sliders section here and pick out a frequency slider, and I'll just attach it here. So that will come up along with the voltage slider. And okay, minimum frequency of 5 Hertz, maximum of 2000 Hertz. Now if I run this, I have a slider here. Now when I adjust this, you can see that I get different frequencies for this sine wave all the way up to 2000 Hertz. It does go up to 5000, so I can actually make this 5000. And let's take a few more samples. 200 is too less, and run this. So now you have, I can adjust the frequency while my program runs. And coming down to sensor add-ons, we have a bunch of experiments, but let's just pick out the data logger. So the data logger here is basically a while true plot some value. Where does that value come from? Any attached sensor on this device. So you have to attach a sensor using the I2C bus. You connect 5 volt supply, SCL and SDL. It's a clock and data lines. First, you need to scan for a sensor. So I have connected this pressure sensor called BMP280. So it's detected it, showed me a small photo to show what it looks like. And it also has three options like pressure, temperature, and humidity. So I've selected pressure. You see, when I run this, it's actually plotting pressure on the right. So it's 991 millibars. Let me try and change the pressure. See, when I change the pressure by just blowing or pulling on the air near the pressure sensor, you see fluctuations like that. And similarly, if I wanted to plot the temperature for this particular sensor, I could use temperature, and it says 27.8 degrees. It's slightly warm because I just blew on that sensor, so it's my breath sort of made it warmer. It's actually cooler. The ambient temperature is slightly lower. It'll equilibrate, of course. So I think that's just about what I wanted to show about this particular interface that's going to be included in the latest update. And here, this is to save the program temporarily, and this is to restore this last saved program. And yeah, so that's pretty much it. This phone section, this will be removed. OpenCV will be removed, probably be replaced with something else. There are some games, the simple silly games, and yeah, so that's pretty much it. Thank you.